So we need to solve the secant of 3x equals the square root of 2. This is the same equation as the cosine of 3x equals 1 over the square root of 2. So I prefer to work with cosine, so that's what I'll use. So we're using the SOHCAHTOA. So we need all the angles whose cosine is 1 over the square root of 2. So this will be adjacent over hypotenuse. Okay, so adjacent over hypotenuse, 1 over square root of 2. So that will be fine in the first quadrant and also in the fourth quadrant. In the second and third quadrants we would get a negative 1 over square root of 2, so we want a positive 1 over square root of 2. Okay, so these are 1 square roots of 2 right angles, and that means these are 45-degree reference angle, or pi over 4. So as pi over 4, I can divide this into 8 slices like a pizza and count off how many fourths pi I have. So here I'd have 1/4 pi, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So I need the 3x to equal either pi over 4, or the 3x needs to equal 7 pi over 4, and then my equation will be true. Now these have an infinite number of solutions because you just need your terminal side to end in either of these two positions. So your terminal side can spin around a couple times before it stops. It can even spin around in the counterclockwise direction before it stops. So what we do is we say plus 2 pi k, and that gives us the infinite number of answers, all of whose terminal sides stop in one of these positions. So this gives us two little equations to solve. We'll just go ahead and multiply by 1/3 to get the x by itself. So multiply both sides of the equation by 1/3 for both equations. That gives us x equals pi over 12 plus 2 pi k over 3, and x equals 7 pi over 12 plus 2 pi k over 3. So these are a description of our infinite number of answers. And now we'll go ahead and take a look at those answers that fall between 0 and 2 pi. So let's let the k equal 0 for our first set of answers. So that would just be x is pi over 12, and x is 7 pi over 12. Then let's go ahead and let k equal 1. So x would be pi over 12 plus 2 pi over 3. I'll have to get a common denominator here, so I'll multiply by 4/4. So let's see, I would have pi over 12 plus 8 pi over 3, no, 8 pi over 12. So 9 pi over 12, and that does reduce to 3 pi over 4. Okay, so there's an answer, and I have these two other answers. Let's go ahead and let k equal 1 over here, so we would have x equals 7 pi over 12 plus 2 pi over 3, and we already saw that was 7 pi over 12 plus 8 pi over 12, so 15 pi over 12, and that also reduces. That would reduce to 5 pi over 4. Okay, how about if k is 2? K is 2, I'd have pi over 12 plus 4 pi over 3. So getting the common denominator, we have pi over 12 plus 12 pi over... Whoops, I should have multiplied by 4/4, shouldn't I? Let's fix that. Okay, now we'll have a common denominator. Plus 12 pi over 12, so 13 pi over 12. And over here x would be the 7 pi over 12 plus the... oh, that should be 16 pi over 12. Okay, we'll get it. 16 pi over 12. And that means we have 17 pi over 12 here. Okay, so 17 pi over 12. And back to this one, 7 pi over 12 plus 17 pi plus 16 pi over 12. And that equals 23 pi over 12. So if we go one more and let k equal 3, then we get bigger than the 2 pi. So we can stop at this point with our 6 answers.